Physics Video Project, Kaya Mooney, Physics 115, Winter 2024. So this is the research question. How does the buoyancy relate to density of a liquid? Density of a liquid. The density of a liquid is measured by its mass per unit volume, which is measured in kilograms per cubic meter or grams per cubic centimeter. Displacement. When an object is placed in a liquid, it places a volume of liquid equal to the volume of the object that is submerged. The amount of liquid that is displaced will have a certain amount of mass and a certain weight, but this is dependent on its liquid density. Displacement and density of a liquid. The volume of a liquid displaced by an object can be used to determine the density of an unknown liquid. Given that we can measure the displacement of the same object in a liquid with known density, water, if the volume displaced by an object in an unknown liquid is greater than the volume displaced by the same object in water, then the density of the unknown liquid is less than the water and vice versa. So in summary, the volume of liquid displaced by an object has a direct relationship to the density of the liquid. We can measure the displaced volume of two different liquids with the same object to determine the relative density of the liquids. Furthermore, if we use a liquid with a known density, we can derive the density of an unknown liquid. So how can the density of an unknown liquid be determined by using the volume displaced? Using the relationship between the volume of a liquid displaced by an object and the densities of two liquids, with one of the liquids having a known density, which is water, we can determine the density of the unknown liquid. Volume of the water displaced, so VW, in relation to the area A of the object, and the height of the water displaced, HW, and the same relation for the unknown liquid displaced volume, VU. And then there I show the equations for those. From those two relations, we can derive a relation between the water and the unknown liquid, since both can be put in terms of the density PO and volume VO of the object. And then there are the equations for that one. To form the relationship, there's the equation for that one. Which can be used to derive the density of the unknown liquid, PU, in terms of height of displaced liquid, HW, HU, and the density of water, PW. How will this experiment work? What is the goal and how will I achieve this goal in this experiment? The goal of this experiment is to determine the density of an unknown liquid. This will be done by using the relationship described in the previous slide, relating density of an unknown liquid, of a known liquid to an unknown liquid, through the use of a constant object to displace volume in both liquids. Through this displacement and the known density of water, we can use the equation to derive the density of the unknown liquid. First, we will measure the displacement of an object in the unknown liquid 3 times for accuracy. Second, we will measure the displacement of an object in the known liquid, water, 3 times for accuracy. Then we will use an analytic tool. I had to use a Logger Pro equivalent, and we will use that to measure the displacement of the liquid in terms of the height of the object submersed in both liquids. From this, we can use the following equation to determine the density of the unknown liquid, given that the density of the water is 1.00 grams per milliliter. Since we know the unknown liquid is milk, we can compare the accuracy of our results to the expected density, 1.25 grams per milliliter. We will use the average of the 3 experiments to find the standard error from the expected density. So for this experiment, I used one bowl filled with water, one bowl filled with liquid of unknown density, which was milk, one object with uniform surface area on the side being submersed, the Logger Pro equivalent, and then I used my phone to record.
Okay, you can go. Make sure it doesn't spill. Set it in gently. Yep. Okay, pick it up. Go ahead.
Actually, you have to wait for it.
It's okay. Yep. And then put it in slowly again. You've been doing good. Cool. Don't spill any water.
Down here?
Mm-hmm. Slow. Let it settle. Wait. Okay.
Good?
Take it out. Okay. You can
Okay, so here is the slide for the object in water. I got the slides mixed up, so the next one will be milk. Here the measurements show the height of the object when it first touched the liquid and the height of the object when it was submersed for 3 trials. So for this slide, we have the analysis of the water trials. Here, so the first one, we have the height of the object. So we got 230.203. Trial number 1, we got 101.0. Trial number 2, we got 102.6. Trial number 3, we got 94.1. And then we averaged all those to get 99.23. And this was for the height of the volume displaced. Okay, so here are the results for the milk. Again, I got the slide switched up. So it says water at the top, but it's milk. Here the measurements show the height of the object when it first touched the liquid and the height of the object when it was submersed. So this is the results for the milk analysis. Again, I got the slides mixed up. So height of the object was 230.203. Trial number 1 for the height of the volume displaced was 79.87. Trial number 2 for the volume displaced was 110.77. Trial number 3 was 120.58, and then the average for all those was 103.74. So here are the calculations of the unknown density. So average height of the volume displaced in milk was 99.23. Average height of the volume displaced in water was 103.74. Density of water is 1.00 grams per milliliter, and density of milk is therefore the 1.0454 grams per milliliter. Comparing the measured density to actual density of milk, 1.035 grams per milliliter, and that shows a percent error of 0.96%.